So what I've done is I've opened Civil 3D and we kind of have a surveyed site of the same kind of project site, and we need to basically create our design here. So we don't have the sidewalk or the gazebo, so we need to sketch that in. But for the purposes of this demonstration, I'm not going to show you how to sketch that in because you should know how to do that by now. And we're just going to pretend that there is a path here and just focus mostly on how do we grade contours in Civil 3D to kind of conform to a specific slope range. So the very first step is we need to determine what is the existing slopes. This is just like when we did it in paper. So in order to do that, we need to know what the vertical is, and we're just going to take these two contours here. So we know it's going to be a 1 foot vertical change, but we don't know what the horizontal distance is. Well, we kind of know, from doing it in paper, but let's just pretend for the sake of demonstration that we don't know what this is. So I'm going to use this measure tool, and I can click here and click here, and that'll give me a pretty close ballpark. But one thing that you have to remember that when you do use this tool is that these two contours are not coplanar. So if I rotate this in 3D, and just kind of try to take a look at this from sideways view, you can begin to see that there is this gradual slope that is occurring. So if I use this measure tool and I measure from here to here, we're not getting the true horizontal distance. We are instead getting the hypotenuse of the triangle. So remember that this is actually looking in section view, so this is a 1 foot elevation change, and we're just picking up the hypotenuse by measuring from there to there, because remember we're snapping from here to there. So let's go back to plan view and think of maybe another more accurate way to do this. So one thing that I usually like to do is use the polyline tool and snap somewhere maybe here, and then type in maybe PERP for perpendicular and try to get perpendicular to here. It's not, super perfect, but it's close enough. And you're probably wondering, well, didn't it snap up to here to here? Well, since I used the polyline tool, this is not going to be a 3D line, it is a 2D line. So we can begin to see that a little bit here. Let me not have that selected. So you can see that we did get the true kind of the run part of our rise over run, where if I was using this measure tool, I would be snapping to here into something up here. See how it snaps up there? And since the polyline tool is pretty much a coplanar tool, it's not going to snap here and go up to there, because this is not a 3D polyline, it's just a regular 2D polyline. It is forced when you snap to here to go just directly below it. So we can see just, from rolling our mouse over it, I think it gave us a little hint on how long this was. I did there for a minute. So let's find out how long this line actually is. So I'm going to select it and type list. And when I do that, it tells me that the length is 10 feet. Alright, so I'm going to go back to plan view. And we know that the length of this is 10 feet and the height is 1, so if we run through our slope equation, we know that there is a 10% slope from here to here. The second step in our process, if you remember from before, is to determine the proposed slope. And again, if you don't know what that value needs to be, we would be looking here on our table, but our client gave us that value and it needs to be a 5% slope, so we already have that information. Third step is determine what the contour spacing needs to be. So again, just like before, we would run through the math, calculate what that needs to be, and we know that it needs to be 20 feet apart. So our proposed contour lines need to be 20 feet apart. So how do we draw contour lines in CAD that are 20 feet apart? So, if you remember from the previous drawing that our existing needs to tie in here, so we probably wouldn't start our grading at elevation 1212. We'd probably start moving this contour here. So I'm just going to kind of just draw in something here really rough, and we're just going to pretend that this is our ramp that our client wants. And I'm going to use the trim tool. So maybe this is where our client is wanting our ramp to occur. So if we go back and we look at our sketch, we know it's about 1, 2, 3, 4, 5, 6, 7, 8 contours over. So it's the ramp kind of terminates at contour 1204, which is here. So I'm going to trim it off there just for the sake of discussion. And this is our ramp. So we need to figure out how these contours are going to behave along this ramp. So again, I'm going to use the polyline tool, and I want to make sure that I'm snapping to that elevation. So before I do that, I need to figure out, let's just say that, it's not going to be, this contour is not going to move to where this contour's position is. In this particular example, it's kind of handy that it is, because you know exactly where to move this contour to. But that's not the case. Let's just say that's not the case. Let's say that the client wanted a 6 or 7% slope, and you calculate out, how far apart the contours need to be, and it's not an even 10. Maybe it's like 15 or 16 or some odd number. Well, one thing that I usually like to do is create what are called ticks. And ticks can be anything. It can be circles, it can be polylines. So I'm going to use polylines. And I know that I need to start grading from this point here, so I'll just create a tick. And then I'll use the offset tool, and I'll type in how far apart that this tick needs to be. So in this case, we decided that it needed to be 20 from our calculations. And I'll just click here and just offset towards the right. And this kind of gives me a hint of where I need to move the contour to. So now I'm going to use my polyline tool and start sketching in my contour. I want to tie in here, and then once I click here, I need to turn off my ortho and my snap. And I'm always going to kind of snap to this contour, and when I do that, I know that my proposed line work is going to pick up that elevation because I snapped to this elevation. We'll see that here in a minute. So for the purpose of this exercise, I'm just going to really roughly sketch this in here. You'll probably want to do a better job. And then once I get close to the end, I'm going to press shift and right click so I can get my temporary snaps up. Choose nearest so I can temporarily snap to nearest. And then press enter to finish that drawing there. So I'm going to do it again now. So now I need this contour to occur here. So again, I'm going to shift right click and choose nearest, so I can snap to something nearest, and then just kind of really roughly sketch this in. And you can definitely go back through here and re-edit this, to make it a little bit more smoother and cleaner. Shift right click again and do another nearest. You can also type, the word nearest instead if you don't want to have to shift right click. So I'm going to try to make this a little bit neater. So that's all I did, was just grab that vertex and just move it. Alright, so let's do some more. Shift right click again, nearest. And usually, towards the end here, I try to curve it so, it looks like it's gradually going to meet back with the grade. If you just abruptly cut it off, the surface gets really rough. You may not see that now, but as we start to build surfaces, you'll see how, there's this kind of like, almost like a pit in the surface. And we'll study that as we start doing a little bit more grading. So I can add a vertex if I wanted to. So as I mentioned, you can go back in here and re-edit this, and you can see that there's a mistake here because this is not correctly spaced. This needs to be over here. So I can maybe grab it from here and move it to here, and then I can take this and try to make it, a little bit more smooth. So when you select on something, you have the ability to basically manipulate it any way that you wish. And one thing that I usually like to do after I'm done grading something is take a look at what it looks like in 3D. So to do that, we would just rotate it. And one thing that I'm really looking for is making sure that something isn't shooting down to like elevation 0. So by turning it sideways like this is kind of a makeshift section view. It gives you kind of an ideal of what that slope is compared to what, the existing is. So basically our ramp would be at the end of these things if we connected a line from here to here to see what that looks like. Alright, so I'll take this back to plan view. And that's pretty much all there is to creating contours using Civil 3D.